greater than 0. This is how we get the domain of the entire function. I don't care about the domain of this. I don't care about the domain of this. I care about the domain of the whole function. So for x plus 3 to be greater than 0 and x minus 3 to be greater than 0, like before with the other example, this means x greater than negative 3, and this means x greater than 3. And when we put this on the real line, negative 3 is here, and 3 to infinity is this. Remember, like last time, we have to choose the common domain. What is the common domain? Where both exist at the same time. So the entire function, natural log of x plus 3 plus natural log of x minus 3 equals natural log 7. What is the domain of this function? Because this is a number. There is no domain on natural log 7.
Is it 3 to infinity?
It has to be 3 to infinity where both exist at the same time. Excellent. So the point I'm making here is this. When I finish solving this equation, if I don't get a number between 3 and infinity, I'll say the equation has no solutions and I'm done. Okay? Now, anybody remembers one of the very important properties of the log? How do I condense this? So there is log of something that is the sum of logs. Anybody remembers what is that? Look at the properties from last time. And let's see how we apply that property to condense this into one log. I need to condense it into one log. There are only 3 properties that we discussed that are characteristic to log functions. Log of a quantity is log of the sum, is sum of the logs. Which property is that? Anybody?
Would it be ln x plus ln 3? Or like for like that property, like where log a plus b. I can't remember how it goes, but something like that.
Okay, so let's go back to the properties from last time. There is no log applied to a sum that does not exist. We don't have log applied to a sum. Log applied to a sum is carved in stone, dead in the water. We only have log applied to a product. We have log applied to a ratio, and we have log applied to a power. There is no log of a plus b. It does not exist. It cannot be changed into anything. It is carved in stone. Which of these properties is applicable in our case? Number 1, number 2, or number 3?
The first one.
Yes, because I have a sum of 2 logs, and I have to go back to this. Very good. So let's see how we write it. How do I condense this into one log?
Is it log natural of x plus 3 times x minus 3?
That's it. Perfect. Now, imagine that we have here 2 logs. They have the same base. What do you think about these numbers? Can this be 25 and this 7? Can this be 100 and this 29? Can this be 2,000 and this 5,000? What do you think has to happen here for these 2 logs to be equal to each other? So 2 logs are equal. What do you think these quantities should be?
The same?
Absolutely the same. Otherwise, it's not going to work. When I multiply, I get x squared minus 9. So this quantity must equal this quantity for the 2 logs to be the same. Absolutely, there is no discussion there. Only log of 7 equals log of 7. Good. So now I know how to solve. This is quadratic. I will move 9 to the other side. And I will take the square root. Remember, it's quadratic. Can anyone give us the 2 solutions? It's quadratic. What solutions?
Plus or minus 4.
Good. But now I did go through the effort. I made the effort to determine the domain. I don't want to go back and check. But I have to look at these and say, uh-oh. And what do I conclude? What is the conclusion?
X equals positive 4.
That's it. No. It's not here. So the only solution is x equals 4. Any questions on this equation? Any questions?
Could you also look at it as subtracting log natural from both sides instead of them being equal? To remove them.
So which log?
Where it says log natural x plus 3 times x minus 3 equals log natural 7, you minus log natural from both sides and then FOIL.
There is no such thing. That is not possible. This is a function. So f of 2x equals f of x does not mean that you can remove the f. This is one function and that is something else.
Got it.
We cannot remove a function. We can apply the exponential function to both sides. That is a different story. Like here. In order to solve this equation, we apply the function to both sides. I cannot delete the power or the base. I can apply a function to both sides. Like here, I could have applied e to the x to both sides, which would have given us the same answer. Or we think in terms of one-to-one function. Natural log, this cannot be 29 and this is 7. This cannot be 500 and this is 7. They will not be the same. Only natural log of 7 equals natural log of 7. So therefore this quantity has to equal this quantity. Because the function is one-to-one. Quadratic functions are not one-to-one. That's why they have 2 options. But natural log is a one-to-one function. For every y, there is only one x. So applying that property, natural log of a equals natural log of b, a has to equal b. There is no other way. Does that answer your question?
Yes, very clear.
Perfect. Good. It's the only way to learn, by asking questions. It's the only way. Thank you. Good. I'd like to look at a word problem now. Are there other questions, please? I'd like to look at a word problem. Let's see. Okay, so something like this, the cooling liquid. A cup of hot coffee is placed on a counter and allowed to cool. The temperature T in degrees Celsius, here it is, uppercase T of T. I don't really like this notation, T plus T. They are different variables, but they could have used anything else. Anyway, what was the original temperature of the hot coffee? What is the coffee's temperature after 20 minutes? And it says T is in minutes, very important, and T, uppercase T in degrees Celsius. So we should always take notes. Degrees Celsius, and here in minutes. Okay. So What was the original temperature? What was the temperature after 20 minutes? When will the coffee's temperature be 35? And then the limit. Okay, so first of all, let's talk about the first two, A and B. So when we say the original temperature, what does this mean? Original or initial temperature. What does it mean? What am I asked to find? And then after 20 minutes. What are we asked to find in the original? Initial.
Is it when time is 0?
Absolutely. Very good. So T of 0. What about after 20 minutes? I know it's silly. It's very clear. What does this mean?
T of 20.
Very good. So of course, I'm not going to do this by hand. I'm going to put the function in. I will plug in 0 and I will plug in 20. 0 is very simple, but and the other one is impossible to do without a calculator. So in y equals, clear the function, and we have 30 plus 45. Careful how you enter it. That's why I want to see it. Make sure that I entered it correctly. Negative 0.03. Oops. Negative 0.0323, sorry. X and close. Make sure the function is entered correctly. Yes, 30 plus 45, e to negative 0.023x. And all I have to do is second and table, go to 0, and go to 20. So the first one, T of 0 equals 75 degrees Celsius. Remember, the measurement unit is extremely important. And T of 20, of course, the temperature decreases, is 58.041 degrees Celsius. Good. So now we have that. So let's move on and see what else they want. When will the coffee's temperature be 35? So the temperature is 35 degrees. But they're asking us when. What do I need to do? What do I need to write? What do I need to solve? I need to find when the temperature was 35.
Should we equal the function to 35?
Yes,
and solve
indeed.
for t?
35 equals 30 plus 45 e to negative 0.023t, and this will be the third or the fourth problem similar. Of course, I'm going to say clean it up. It's not cleaned up. We can't apply anything. We cannot change anything till we clean it up fully. So what do we do?
Subtract 30 from each side.
Very good. Excellent. Next step is still not cleaned up.
To divide by 45.
Yes. So 1 divided by 9 equals e to negative 0.023t. I simplified by 5. Good. Now it's cleaned up. Now I can think in terms of doing something to both sides to solve it. What do we do?
Apply log natural to both
Natural
sides.
log to both sides. Perfect, because the base here is e. Excellent. To make it easier. Any log will do, but it's easier because it's base e. So natural log of 1 over 9 equals negative 0.023t. I brought the power in front because natural log allowed us to do that. This is the third property. And now this is a linear equation. This is just a number. It looks fantastic, but it's just a poor number. So then t equals natural log 1 over 9 over negative 0.023. Careful in the calculator, you have to put parentheses around the denominator. Maybe it works without it. I even refuse to try to see. Okay, you can try it if you want. Okay, So, okay, so we have natural log 1 divided by 9 divided by, in parentheses, negative 0.023. And see, I didn't put the negative. I said it, but I didn't. Okay. Okay, now I did another boo-boo. Okay, so
For
natural,
this calculator, if you do second y equals, you can input a parenthesis with like numerator denominator. It's easier that way.
okay, very good, with the feature right here with parentheses. Okay, very good. Okay, so this is t equals 95.5 minutes. Okay. Good. Final question. They're asking us to find the limit of this function as t approaches infinity. So this is part D. What am I doing there? And they want us to find the limit as t approaches as time approaches infinity from 30 plus 45 e to negative 0.023t. One way is to think about it. So let's think about it. And the other way is with a calculator. So let's first think about it. When t approaches infinity, what do you think this will approach? So I'm multiplying the left-hand side, so negative 0.023t. If t approaches infinity, this times this will approach what?
Zero.
Negative times infinity will approach negative infinity. It's a tiny number, but it doesn't matter. This is infinity. Negative, any number, small or big, doesn't matter, times infinity. It's negative times infinity is negative infinity. Now, we're talking about this piece. So we're talking about e to negative infinity, which is 1 over e to infinity, which indeed approaches 0. Because I divide a small number by a huge number. We discussed that in the previous chapter. So this approaches 0. 0 times 45 will approach 0, so the limit is 30. What does this mean? Well, the exterior temperature or the room temperature is 30. Nothing can go lower than the temperature of the environment. So I have the cup of coffee at 75 degrees, and the lowest it can go is the temperature, the room temperature. So the limit is 30 degrees Celsius. Okay. If this was somewhat abstract for you, all we have to do is go to the calculator, punch the function in, which you already have. That's another reason why you should always have the function punched in, and just plug in numbers, bigger and bigger, bigger and bigger, bigger and bigger. So I'm just going to plug in 2,000 minutes. I'm going to plug in 5,000 minutes. I'm going to plug in 8,000 minutes. It's already done. It cannot go any further, any lower than 30. So therefore, the limit of the function as time goes by, passes with no limit, is 30, because that means that the temperature of the environment is 30. It cannot go lower.